In section 4.2, we are going to look at the mean or expected value and the standard deviation. The expected value is often referred to as the long-term average or mean. So this means that over the long term of doing an experiment over and over, you would expect this average. An example would be you toss a coin and record the result. What's the probability that the result is heads? If you flip a coin 2 times, does the probability tell you that these flips will result in 1 heads and 1 tail? You might toss a fair coin 10 times and record 9 heads. Probability doesn't describe the short-term results of an experiment. It gives information about what can be expected in the long term. To demonstrate this, Carl Pearson once tossed a fair coin 24,000 times. He recorded the results of each toss, obtaining heads 12,012 times. In his experiment, Pearson illustrated the law of large numbers. When evaluating the long-term results of statistical experiments, we often want to know the average outcome. This long-term average is known as the mean or expected value of the experiment and is denoted by the Greek letter mu. In other words, after conducting many trials of an experiment, you would expect this average value. To find the expected value or long-term average mu, simply multiply each value of the random variable by its probability and add all the products. Let's take a look at an example. A men's soccer team plays soccer 0, 1, or 2 days a week. The probability that they play 0 days is 0.2. The probability that they play 1 day is 0.5, and the probability that they play 2 days is 0.3. Find the long-term average or expected value mu of the number of days per week the men's soccer team plays soccer. To find the expected value or long-term average mu, simply multiply each value of the random variable by its probability and then add everything up. So to do this problem, we're going to first let the random variable x equal the number of days the men's soccer team plays soccer per week. So x takes on the values 0, 1, or 2. Then we're going to construct a PDF table, adding a column of x times the probability of x. In this column, we will multiply each x value by its probability. Once we do that, we get the expected value of 1.1. So what this means is the men's soccer team would, on the average, expect to play soccer 1.1 days per week. The number 1.1 is the long-term average or expected value if the men's soccer team plays soccer week after week after week. So we say mu is equal to 1.1. In this example, you're playing a game of chance in which 4 cards are drawn from a deck of 52 cards. You guess the suit of each card before it's drawn. The cards are replaced in the deck on each draw. You pay $1 to play. If you guess the right suit every time, you get your money back and $256. What's your expected profit of playing the game over the long term? So we're going to let x equal the amount of money you profit, and the x values are -1 and 256. So the probability of guessing the right suit each time is 0.0039. So the probability of losing is 0.9961. So mu equals 0.23 cents. You would, on average, expect to win approximately 23 cents for each game you play. However, each time you play, you either lose $1 or profit $256. So the 23 cents is the average or expected win per game after playing this game over and over.